Hello everyone, we are delighted to present our work in the ICMPC 2021. The topic is Music Emotion Recognition from Lyrics using Transformer-Capsule Network. Music plays a vital role in our lives. Individuals seek varied range of emotional experiences via music. Extracting emotions from music has been a very exciting field of research, not only to correlate it with the underlying musical structure and therefore get deeper insights into perception of music evoked emotions, but also to create a hyper-personalized music recommendation systems, as you often see them around in our daily lives. While this is really interesting, it comes with its own fantastical challenges in performing the music information retrieval for emotions in an automated fashion and using machine learning. This can be easily understood in a multimodal setting, primarily due to the fact that our perception of music is a multisensory integration phenomenon. We are particularly interested in using lyrics to derive these musically induced emotions. Traditionally, music emotion recognition tasks depend heavily on acoustic content, social tags, and metadata. However, lyrics play a crucial role in evoking emotions. Emotion recognition from lyric has been traditionally an underexplored area because of rich acoustic level research dominating the emotion prediction for some obvious reasons like maturity of signal processing techniques, etc. However, the significant technological advancements in the field of natural language processing have led to very novel and improved ways of analyzing the text and extracting the relevant features such as topics, sentiments, and emotions. This has further captured the attention and growing interest in the machine learning community to apply these natural language processing based computational models for extracting emotion using lyrics. So identifying emotions via lyrics involves identifying emotional connotation of lyrics, which can be with these natural language processing techniques and projecting them onto an emotional space, VA space, where valence represents pleasantness and arousal represents energy level. Discrete emotion categories such as happy, sad, amongst others can be evaluated based on the precise position in this continuous valence arousal space. For instance, the positive quadrant and the positive arousal is related with happiness, while negative arousal and negative valence represent quadrant associated with sadness. We used Moody Lyrics dataset to evaluate the efficacy of the proposed architecture. Moody Lyrics contains 2,595 songs distributed across the four quadrants of the VA space. The emotional connotation of songs in Moody Lyrics were a combination of natural language processing techniques in addition to the manual validation of the congruence with user-specified mood tags associated with the tracks, which are typically assigned based on audio and lyrics combined via common lexicons like ANU. The most represented emotions were retained. Collected texts were first pre-processed, removing empty or duplicate songs, punctuation symbols, stop words as well, etc. Previous studies used word-level analysis, word-level embedding, which were obtained by emotion-based lexicons. Some limitation to this approach are that these lexicons are not only limited by the vocabulary, but word-level emotion values were aggregated without any contextual information. Now, with the advent of deep learning, recent studies on music emotion recognition introduced pre-trained word embeddings, which could model the sequential information. But it still lacks in encapsulating the emotion, which can vary with sequence and phrase level, and was still limiting to model the long-term dependencies with desired contextual information. So something more was needed to model the selective attention in the sequencing to create some level of contextual summary. That is where transformer models came into the picture. So it was natural to look into this architecture, and it gave superior results in this task by Agarwal et al. 2020 study. The results beat the state of the art. Now the question we started asking was if this structure closely mimics the music processing in human brains. Are there novel architectures which can strive to do this and we get a better chance to interpret its working in the context of music emotion recognition? Our quest ended, or we can say it resulted in some quenching of our thirst about it, with something called a capsule network, built on top of the transformer network. Our study extends a previous work which uses transformer-based approach towards music emotion recognition from lyrics by investigating a novel machine learning architecture that mimics human processing of information. So why capsule? The main intuition of capsule was to group a related information while ensuring that relation between features stay intact. The capsule network architecture was unsurprisingly conceptualized by Geoffrey Hinton in a seminal paper in 2018, where he described this as the network which mimics human cognition. It was primarily evidenced in the image recognition and was shown to have a significant improvement over the classical deep convolution neural network, since CAPSNets prevented the loss of information in aggregating, thereby providing a novel way in which inter-feature relationship is preserved. For example, in a quick comparison, the classical deep neural network for an image recognition task, if it's a panda or not, will only bother that there are two eyes, one nose, etc. But it will not be concerned if they are spatially coherent. Whereas, if you look at a CAPSNet, it will retain information on relative location of nose and eye, thus a better feature detector. This turns out to be a vital insight for the missing piece we were looking for in understanding the emotion extraction beyond the computational prowess of the transformer architecture. And in many ways, it becomes immediately pertinent in our problem setting, where we are attempting to go beyond the syntactic to learning semantics by feeding all the information rather than losing some of it in summarizing, etc. So the capsules are akin to neuronal populations breaking down information into parts that mimics human processing of information by chunking for efficient encoding and evaluation of the stimulus, something which comes close to human cognition. We modified the transformer architecture proposed in the work done previously to use capsule-based the capsule-based architecture. In our architecture, rather than only feeding a summarized information which has selective attention mechanism, we feed the raw representation directly along with the summary to a deep layer. Not just that, we then have the super capsule classification layer where all input is fed to allow the decisioning of grouping the relevant information by network. It's really like feeding all kind of low-level representations to an intelligent brain, which will group them together while learning the relationship between the features and not incurring any loss of information along the way. So the classification accuracy plots show the highest accuracy for happy, which is 98%, and lowest for sad, 93%. All other accuracy is also noteworthy. The misclassifications predominantly along the valence axis, which is also typical in music feature-based emotion recognition. This suggests that a hybrid model that combines sequential syntactical processing and hierarchical semantic processing models accurately capture human judgment of emotions from lyrics. Limitation with this work is akin to limitation for any complex deep neural network. You need a lot of data to really find the efficacy in generalizable models. A natural extension of this work is to explore unsupervised models so that one can learn from a lot of data which is yet to be annotated for supervised learning. Last but not the least, the world would always be keen to look beyond the English. Thank you. We are ready for the questions.